Okay. Good morning. So in this class, we will discuss some problems on planar graph. Okay. So for this, we need two results. One is if G is that is Euler formula we need. Okay. So what is Euler formula? N minus E plus F equal to 2. Okay. So we need this formula N minus E plus F equal to 2. Okay, this is Euler formula. So n minus E plus F equal to 2. Okay, next one, this result, if G is planar graph, then okay, the number of edges is less than or equal to 3n minus 6. Okay, if G is a planar graph, if G is a planar graph, planar graph. So this result is also true for what? Planar graph. Okay, this is okay, planar graph. If G is a planar graph, then uh, then E, number of edges of G. So E less than or equal to n minus 6. So 3n minus 6, sorry. 3n minus 6. Or you can write E of G. Here also you can write n of G. So E means number of edges in G. N means number of vertices in G. So using this result, we are going to discuss some of the problems. Okay. So I'm not going to, I think around 15 problems. I'm not going to solve all the 15. Some of the important problems only I am going to discuss with you. So here you can see this. Okay, I'll take the snapshot quickly and then wait here. Okay. So the question is here, if G is what? G is a graph with 1,000 vertices and 3,000 edges. Is G is planar? So this is the question. Okay, a graph G is planar. Okay, just now I told you G is planar, then E is less than or equal to what? 3n minus 6. So instead of E, they will give what? Q. So you can take E also here. Okay, E less than or equal to what? They'll take instead of P, they'll take what? Instead of N, they'll take P. Okay, so even I can take E less than or equal to what? 3n minus 6. So here n equal to what? Number of vertices 1,000. E equal to what? Number of edges 3,000. So if I substitute in this inequality, E is what? 3,000 less than or equal to 3 into n minus 6. Okay, or what is n? N is 1,000. N 1,000. Okay, 1,000 means 3 into directly you can put E is what? E is 3,000. N is 1,000. So 3,000 minus 6. So from this 3,000 less than or equal to what? 2,994. So which is impossible. So which is a contradiction. So which is impossible. Okay, okay, which is impossible. So hence the given graph G is what? Is not planar. Okay, wow. So if it is planar, okay, wow, if G is planar, it should satisfy this condition. If this condition is not satisfied, okay, wow, then G is not planar. So that is the idea. So this condition is not satisfied, and hence the given graph G is what? Is not planar. I will go to the next problem. Problem number 4. So in problem 4, okay, so here see that here a connected graph has 9 vertices having the degrees. So the degree of the 9 vertices are mentioned here. The question they are asking are how many edges are there, how many faces are there. Okay, so this is a question. So I'll take a snapshot. Okay. So in this question, okay. So here, what is given in the question? A connected graph having 9 vertices. So how many edges are there? They're asking what? Q or E. They're asking what? Either you can put, okay, here they are putting what? P minus Q plus R. Here usually we say what? N minus E plus F. They will tell like this. Okay. So if you want to use their notation, you can use their notation, no problem. Mm. So the number of edges means we need to find Q, and also now we need to find phase or region. We should find what? R. Okay, we need to find Q and R. Okay, these two. So what is the formula? We should find what is the formula? Euler's formula. P minus Q plus R equal to what? 2. This is a formula. So if you know two parameters, then only you can find the, because we have 3 parameters. So from the 3 parameters, if you know any 2, we can find the remaining one. So this is the idea. But here they are asking what? Uh, we have only one now. P is what? Number of vertices is what? 9. So 9 vertices we have. So from this you cannot find what? Because I know only one parameter. The remaining 2 parameters I need to find out. So but they gave that some hint in, okay, indirectly. So each of the vertices has what degree, what they gave. Okay, 2 2 2 3 3 3 4 4 5 5. So from this, okay, and using handshaking lemma, sum of the degrees of the vertices equal to twice the number of edges. So, okay, that is we studied. So what is the lemma? Sum of the degrees of the vertices, okay, from here to here. Sum of the degrees of the vertices, okay, is equal to what? Twice the number of edges. So if I add everything, we'll get 28. From this, you can get what? Q. Q is 14. Now I got Q is what? 14. So P is what? 9. P is 9. Q is what? 14. Now you can find the third parameter. So, okay, this is what? Minus 5 plus R equal to what? 2. So R equal to what? 7. So, uh, so hence there are Q equal to what? Q equal to uh, uh, Q equal to 14. Okay, Q equal to 14. They're asking, and then what? R equal to region is what? 7. That's a problem is over. Next, fifth problem. Maybe I will explain using PPT. I don't need fifth problem. I think fourth I finished. Fifth one, yes. Okay. So in the fifth one, uh, okay. Well, find a graph G with a degree sequence. They gave a degree sequence 4 4 3 3 3 3, such that you need to draw a graph G using this degree sequence. First subdivision, you should draw a planar graph. Second one, you should draw a non-planar graph. Okay, okay, using what? This degree sequence. From this, you can easily find the total number of vertices is what? 6. So for subdivision 1, we have drawn a planar graph with 6 vertices with the degree sequence as shown in this figure. You can check it. Totally how many vertices? 1 2 3 4 5 6 6 vertices. two vertices are what? Degree 4. So these two vertices are what? Degree 4. Remaining vertices 3, 3, 3, 3. So this is a planar graph. Why it is a planar graph? Because the edges are intersect only at the end points. Okay, it will not cross anywhere else. So that's why this is the planar graph. So we draw. First subdivision is over. For the second subdivision, they are asking to draw a non-planar graph using this degree sequence. Okay, by handshaking lemma, sum of the degrees of the vertices equal to what? Twice the number of edges. So 2q is equal to 2 times number of edges equal to, if you add the degrees, 4 plus 4 plus 3 plus 3 plus 3, so you will get what? 2q is equal to 20. From this you can find q equal to 10. Okay, so q equal to 10 is, that means what? The number of edges is what? 10. Number of vertices is what? 6. So suppose, okay, uh, the graph is a planar, then it should satisfy the inequality. What is the inequality? Q less than or equal to 3p minus 6. We are telling E less than or equal to what? 3n minus 6. So Q is what? Q is 10. 3 into P. 3 into P. P is 6 minus 6. This implies, okay, this implies what you'll get? 10 less than or equal to 18 minus 6. So 10 less than or equal to 12. So if G is planar, this condition should be satisfied. Yes, this condition is satisfied. If this condition is satisfied means, okay, actually, uh, so suppose if G is not, G is what? Non-planar means this condition is what? Not satisfied. So hence it is not possible to draw a non-planar graph, okay, with the degree, with the given degree sequence. Okay, sixth problem. Determine the again uh, this is you, they are used. Okay, first I'll read the question. Determine the number of region. They are asking R. So what is given? P is given. P is what? 6. Q is given. They gave two parameters. They are asking the third one. P equal to 6, Q equal to what? 10. So and also they are asking draw a simple and non-simple graph. So by Euler's formula for a planar graph, P minus Q plus R equal to what? 2. What is P? 6. Q is 10. R we need to find out. Okay, so from this you can easily find R, because this is what? Minus 4. So R equal to 2 plus 4, 6. So the region is what? 6. So using P equal to 6, Q equal to 10, R equal to 6, we need to draw simple graph and a non-simple graph. Simple graph means there is no parallel edges and there is no loop. Non-simple graph means the loops and the parallel edges are allowed. Here they are using parallel edges. So this and this are what? Parallel edges. This and this are what? Parallel edges. Okay, this and this are parallel edges. Similarly here, this and this are what? Parallel edges. So you can check it. How many vertices? 6 vertices. Check the number of edges, and the region is what? 6 region. 1, 2, 3, 4, 5. Sixth one is what? Infinite region. Next, seventh problem. How many edges must a planar graph have if it has 7 regions and 5 vertices? Again, they gave two parameters, R and P. They are asking Q. Okay, so again Euler's formula, P minus Q plus R equal to 2. So they gave P equal to what? 5 and R equal to 7. They're asking Q. So again N minus P is what? 5. Q I don't know. R is what? 7 equal to 2. From this you can easily find what? Q. So Q equal to 10. Now draw one such graph. One such graph means using P equal to 5, r equal to 7 and q equal to 10, we should draw a graph. So these four graphs satisfies p equal to 5, r equal to 7, q equal to 10. So you can draw any one of the graph. So next problem, by redrawing the following graphs, show that the following graphs are planar. So just you need to from this graph to you should redraw this graph such that the edges should intersect only at the end points. Similarly, you should redraw this graph like this. What is the condition? Only condition is the edges only intersect at what? End points, because here they intersect like this. Okay, in the middle. Okay, but here there is no intersection. So the edges intersect only at the end points here. Okay, next, draw all planar graphs with the 5 vertices which are not isomorphic to each other. So planar graph with the 5 vertices which are not isomorphic to each other. So we know that K5 is not planar, but okay, this is what? 5 vertices planar. Next, I'll add this edge. I'll get this graph. Next, from in this graph, I'll add this edge. I'll get this graph. Next, I will add this edge. I'll get this graph. Next, I will add this edge. I'll get this graph. Next, I will add these two edges. I will get this graph. So that's all. Okay. If I add one more edge, okay, for degree 4, degree 4, degree 4, 4 is 4. This is also degree 4. Degree, this is degree 3. This is also degree 3. 1, 2, 3. So you cannot add these two edges. Okay, because if I add these two edges like this, it will cross this edge. Similarly, if I add, suppose if I come like this, it will cross this edge. Suppose if I come like this, if I go again, okay, so you cannot draw a graph without crossing the edges. Okay, so these are all planar graph with 5 vertices. Okay, but all are not isomorphic because I am adding from here to here. I add one edge. From here to here, I add what? One edge. So they are all not isomorphic to each other. This is not that much important. That's why I'll skip this one. Okay, next one. Okay, maybe I take a snapshot. So in this problem, okay, first I'll read the question. Show that there does not exist a connected simple planar graph with the m equal to 7 edges and with the degree minimum degree delta equal to 3. So we should show that there does not exist a connected simple planar graph with the number of edges is what? 7, and with what? Degree minimum degree is 3. Suppose there is a graph G, okay, of the desired type is exists. Suppose we assume, but we know that this result already. Which result? Uh, Delta minimum degree. Okay, minimum degree delta less than or equal to 2m by n less than or equal to what? Capital delta. So this, okay, I'll use only this portion. Okay, here delta is what? Less than or equal to 2m by n. I am taking from this inequality, I'll take this part only. So from this, what is n? N is what? N I don't know. Okay, but I know delta. So n delta less than or equal to what? 2m. N is what? I don't know. Okay, delta is what? 3. So 3m less than or equal to what? 2 into m. M is what? 7, 14. So this implies, okay, 3m less than or equal to what? 14. Yes, okay. So this is the first observation. 3m less than or equal to 14. Next, on the other hand, if it is, okay, uh, suppose next one, uh, suppose there is a G of the desired type. That means what? So G is a planar graph. Okay, G is what? A planar graph of the desired type means G is a planar graph with what? The number of edges is 7 and with the minimum degree is delta. So G is planar. Okay, G is planar implies so n, okay, sorry, e number of edges less than or equal to 3n minus 6. This inequality is true if G is planar. So that's why I'm taking this result. But e number of edges is what? 7. 7 less than or equal to 3n minus 6, or you can write, sorry, or you can write uh, 6 13 less than or equal to what? 3m. 7 plus 6 13 is less than or equal to 3m. So this is the next observation. So now there are two observation. Okay, now from this I combine these two observation. So 3n or 13 less than or equal to 3n, 3n less than or equal to what? 14. So that is the gave. Actually, which is not possible. Why which is not possible? So is it now we know that n is an integer, positive integer. Okay, so but you need to find a positive integer which satisfies 3n should be lies between what? 13 and 14. Is it possible? It is not possible. Because 13 and 14 are two consecutive positive integer. So we cannot find a positive integer n such that 3n is lies between what? 13 and 14. So and hence hence the graph of the desired type does not exist. That's all. Next, problem 11 is over. Next, problem 12. Okay, in problem 12, so show that every simple connected planar graph G, okay, with less than 12 vertices. So less than 12 means maybe 11, 10 like this. Less than 12, okay, less than 12 vertices must have a vertex of what? Degree less than or equal to 4. Okay. Suppose I am assuming every vertex of G has degrees what? Greater than or equal to 5. Okay. Because I need to prove what? Uh, I need to prove, suppose G is a planar graph, the less than 12 vertices means I need to prove what? The degree of the each vertex is what? Degree of, okay, yes, 12 vertices must have a vertex of degree 4. So at least one vertex. So again, because we should understand the statement clearly, show that every simple connected planar graph G with less than 12 vertices. Less than 12 means G has 11, 10, okay, 9, 8, okay. Less than 12 vertices must have a vertex of degree what? Less than or equal to 4. Okay, at least one vertex of degree 4. Suppose I am assuming contrary. So suppose every vertex here, every vertex of G has what? Degree greater than or equal to 5. So that means D1, D2, Dn. I don't know the number of vertices. So that's why I'll take D1, D2, Dn are the degrees of the n vertices of G. So by assumption, each of the degree it should be what? Minimum what? 5. So if you add all the degrees, okay, or D1 to D5, so this is greater than or equal to what? 5 times n. Okay, 5 times n. So but the sum of the degrees is equal to what? Twice the number of edges, 2m. Okay, that is greater than or equal to 5m by handshaking property. Okay, from this pi n by 2 less than or equal to m. Okay. So on the other hand, if G is a planar graph, what you know? Number of edges E less than or equal to where there we are using E, here they are using what? M. M less than or equal to 3n minus 6. This is the result already we proved for what? Planar graph. If G is planar, this is always true. Now, from 1 and 2, you can write phi n by 2. From this, we are writing what? Phi n by 2 less than or equal to what? Directly. Okay. So, phi n by 2 less than or equal to m, but m is less than or equal to what? 3n minus 6. So phi n by 2 is less than or equal to 3n minus 6. They are written directly. Or phi n by 2 less than or equal to phi n by 2 less than or equal to what? Less than or equal to 3n minus 6. 3n minus 6 or phi n less than or equal to 6n minus 12 or 12 less than or equal to what? N. So this implies the number of vertices is what? At least 12, so which is a contradiction. Why it is a contradiction? Because in the statement, G should be what? The number of vertices, G is a planar graph, the less than 12 vertices. Now, I got n is what? Greater than or equal to 2. The number of vertices is what? Greater than or equal to 2. Why I got why I got n is greater than or equal to 12? The reason is I assumed what? Every vertex of G has degrees what? Greater than or equal to 5. Okay, because of this only, I got what? N greater than or equal to 12. So, and so hence if G has less than 12 vertices, it must have a vertex, at least one vertex, okay, whose degree is what? Less than 5 or less than or equal to 4. That's all. So this is end of the problem. Next one, 13. Show that the condition m is what? Number of edges, or you can take e less than or equal to 3n minus 6 is not sufficient condition for a connected simple graph with n vertices and m edges to be planar. Okay, so we know that G is planar. Okay, then m is or e is less than or equal to 3n minus 6. But in this problem, they are telling if m less than or equal to 3n minus 6 does not imply G is what? Planar. So for this, we should give one example. Okay, consider the graph K33. Okay, K33 means you should put in suffix K33 like this. You cannot write like this. Okay, K3, 3. So K33 is a simple connected graph which has 3 plus 3, 6 vertices and 3 into 3, 9 edges. So if suppose it is a planar, then it should satisfy this condition. Okay, so I'm checking. We check for this graph m less than or equal to 3n minus 6. So here what? Okay, m less than or equal to what? M less than or equal to 3n minus 6. What is m? M is what? 6. Sorry, 9. M is 9. Less than or equal to 3 into 6, 18 minus 6. But 9 less than or equal to what? 12. So actually this is satisfied. Okay, this condition is satisfied, but we know that what? We know that K33 is what? Already we proved what? It is non-planar. Okay, so even though this condition is satisfied, okay, but K33 is what? Non-planar. So that's why they are telling this is not a sufficient condition. Okay, sufficient condition means what? If this is satisfied, okay, then okay, the graph G is what? Suppose I am assuming this is a sufficient condition for planarity, means if this condition is satisfied, G should be what? Planar. Okay, so actually we know G is planar. Then this condition is satisfied. That's all. Okay, so if this condition is satisfied, does not imply what? G is planar. So that's why they are telling this is not a sufficient condition, because in K33 this condition is satisfied, but K33 is what? Non-planar. Okay, next problem, 14th problem. What is the maximum number of edges possible in a simple planar graph with the 8 vertices? Okay, so 8 number of vertices is 8. So they're asking what? Maximum number of edges. So again, I'm going to use the result m less than or equal to what? 3m minus 6. So if I substitute here 8, so 24 minus 6 is what? 80. So maximum, how many edges? Maximum number of edges is possible is what? 80. Next. And what is the minimum number of vertices necessary for a simple connected graph with 11 edges to be planar? Okay. So for a simple connected planar graph n comma m graph, suppose it's a planar graph, then m is less than or equal to what? 3n minus 6. This result we know that. Okay, wow. So maybe I'll take a snapshot and then I will discuss. So what is the minimum number of vertices necessary for a simple connected graph with 11 edges to be planar? Okay. So if it is a planar graph with the n comma m graph, n comma m graph means n vertices and m edges. So for a planar graph, m is less than or equal to 3n minus 6. Okay, from this, m is less than or equal to what? 3n minus 6, or you can write 3n greater than or equal to, okay, 3n greater than or equal to, or m plus 6 less than or equal to 3n, okay, or n, okay, n is greater than or equal to n is greater than to m plus 6 by n is greater than to m plus 6 by 3, but okay, m is greater than to 3n plus 6. If m is 11, okay, I think, yeah, n is greater than or equal to m plus 6 by 3. I think this is correct. I think so. We'll check it. N is greater than or equal to m plus 6 by 3. Okay. Now n is greater than or equal to, m is what? Number of edges is 11. 11 plus 6, okay, by 3. So which is equal to 17 by what? 3. So and hence n is greater than or equal to 17 by 3 means n should be an integer. So this is what? 5 point something. So and hence the number of minimum number of vertices should be what? At least 6. So from this, because n is an integer, positive integer. Okay. Next, I think, yeah, so we'll discuss one or two problems and then we stop. Okay. This problem, determine whether the graph shown in this figure is planar. Okay, I think we know that K phi is what? Non-planar. So this is non-planar. Okay, and already I told to you a graph which contains K phi or K33 as a subgraph is also what? Is non-planar. So look at this graph H. So here look at A, B, C, G, I. A, B, C, G, I. So actually A, B, C, G, I is a complete graph on 5 vertices, which is a subgraph in capital H. So that's why this is also what? Not non. This is also non-planar. This is also non-planar. Similarly, this graph G is also non-planar because this also contains A, B, C, G, I. Okay, okay. Uh, is it contains K5. This graph G is also contain what? K5 as a uh, K5 as a subgraph. Okay, so that's why this is also what? Not a this is non-planar. This is also non-planar. This is already you know that K5 is non-planar. Last problem. I think this problem I started in the previous class and then I stopped this one. Okay. So every region of a simple paragraph with n vertices and e edges embedded in a plane is bounded by k edges, then show that e equal to k into n minus 2 in n minus 2 e equal to k into number of edges is equal to k into n minus 2 divided by what? K minus 2. Okay. Here, before going to, okay, so first you should understand the question. So every region, okay, G is what? G is a planar graph with n vertices and e edges. So every region of this planar graph embedded by in a plane bounded by what? Every region is bounded by k edges. Just okay, you should take like this. Every region of a planar graph bounded by what? K edges. So since every region is bounded by k edges, so suppose there are R region, okay, in the graph means the R region is bounded by what? So each region is bounded by k edges means R regions are bounded by kr edges. Okay. So also each edge is counted twice, once for two of its adjacent regions. So 2e equal to kr. So I should explain why it is 2e equal to kr. Okay, so maybe I will explain here. Look at this graph. Okay, in this graph, how many faces? One, two, three faces. Okay, here four edges. This face bounded by this face is bounded by what? Three edges. Again, the third face is bounded by one, two, three, four, five, six, seven edges. So totally 14 edges. Okay, or totally 14 edges. So here, uh, here, that means we are taking this is nothing but what? Okay, this is nothing but sum of the degrees of the faces. Okay, 4 is what? Degree of face 1. 2 is what? Degree of sorry, 3 is what? Degree of face 2. 7 is what? Degree of face 3. This is nothing but what? Sum of the degrees of the sum of the degree of the faces. So this is equal to 14 means total number of edges is what here? 1, 2, 3, 4, 5, 6, 7. So this is you can write 2 into 7. 2 into what? Edges. So sum of the degrees of the faces equal to 2 times the number of edges. Okay, so this is the idea. Now, okay, look at the another example. Here, just I'll take only this. This is phase 1, phase 2. So here, each phase is contains what? Phase 1 contains how many edges? 4 edges. Phase 2 is also what contains what? 4 edges. So that's why I told here in this each phase. Okay, every region is bounded by k edges. Here, k is what? 4. K is what? 4. Uh, R is what? 2, because the region is 2. Okay, so so we'll get what? K plus k equal to, sorry, 4 plus 4 equal to 2. Sorry, 4 plus 4 equal to 8. Okay, so this is nothing but 4 plus 4 is nothing but what? Sum of the degrees of the faces. Sum of the degree of face equal to 8 is nothing but 2 times the number of edges in the graph. 2 times E. E is what? 4. So that's why, okay, instead of from this motivation, okay, total number of okay, sum of the degrees of the faces, okay, is what in our graph, because we have r faces, okay, each face is bounded by what? K edges, each face. So sum of the degrees of the faces in our graph is kr or rk is equal to twice the number of edges, 2e. So that's why we get what? Kr equal to 2e. Kr equal to 2e. From this, r equal to what? R equal to 2e by k. Okay, once you got this, remaining everything is easier, because this is Euler's formula, n minus e plus r equal to 2. So from this, n minus e plus r equal to what? 2e by k equal to 2. Throughout multiply by k. So nk minus ek plus 2e equal to 2k. So from this, simplify and get e equal to what? K into n minus 2 by k minus 2. So only thing, this is this idea. Okay, you should understand why kr equal to 2e. Okay, so kr is nothing but what? Okay, so r is the total number of faces. K is what? Each face is bounded by k edges. Here in this graph, each face is bounded by what? 4 edges. Okay, wow. 4 edges. So that's why k is what here? 4. 4 into r is what here? 2. So equal to 8. 8 is nothing but what? 2 into number of edges is what? 4. So in this graph, this is what? Uh, k, okay, into this is what? R equal to 2 into E. Okay, so this is particular example. In general, okay, we are telling kr is nothing but what? Sum of the degrees of the face is equal to twice the number of edges. Okay, so once you got this one, and remaining everything easier in this problem. Okay, so I think I finished up to planar graphs. Uh, Still we have coloring and chromatic polynomial and coloring. So I can't finish uh, today. Okay. So maybe I will take the lecture videos as after CA, and then I will post it. Okay, thank you for your support. Okay, thank you once again.